Hi there, welcome to IRT Surveys CPD presentation. Today we're going to take you through infrared thermography, what it means, what it stands for, and places where you can use it and see the benefit of actually seeing defects. IRT Surveys are currently the largest infrared building surveying company in Europe. We were established in January 2002 and we focus predominantly on buildings and energy. We've got 11 offices around the UK under franchising, and we operate as a bureau service whereby every franchisee around the country physically sells the service and provides data capture, but everything they take is uploaded to Dundee for analysis and processing. To that end, we've patented some software that we will go on to later on, but the core services involve infrared thermographic surveys, electronic leak detection, which basically pinpoints holes in roofs, and two new things I'd like to show you later on about carbon dashboards and carbon diet plans. So without further ado, let's get stuck in. That's the company there, that's the structure. Myself and my brother are on the top of the screen. I'm ex-architectural. My brother's a scientist. Dave Jones in the middle there is a non-executive director in the business and author of computer games like Lemmings, Grand Theft Auto, David Beckham Soccer, etc. And then we've got two ladies in the company that keep us straight. Nikki Thomas travels around the country making sure our franchisees are happy and that they toe the line, which is a challenging role. Franchisees are across the country, various backgrounds. The company itself is backed by an investment capital company called Sigma. You can see their logo over here on the left hand side. We were in the Carbon Trust Incubator Programme for around 12 months. And as you'd expect, we've got various professional bodies accrediting us, such as the British Institute of Non-Destructive Testing, and we're members of the UK Thermographic Association. We also are invested in by the Scottish Government and the Scottish Building Standards Agency. We've actually done quite a bit of research with them to establish our credentials. And again, as you'd expect, we're members of Construction Line and CHAS, which is a health and safety body. Since we started, we've surveyed around 16 million metres of flat roofs in the country, various university campuses throughout the UK, and certainly hundreds of schools to help rank and rate them. Core business is offices and retail warehouse facilities, although we have done an awful lot of supermarkets around the UK. Since about 2008, maybe even 2009, we started doing housing stock surveys in quite a big way. And our projects have gone from as far west as Los Angeles and as far east as Azerbaijan. Typical clients for us range from individual householders up to major UK brands like British Gas, Sheffield Insulation, E.ON, quite a broad spectrum really. Majority of our business comes from building surveyors like Knight Frank, like Savills, Jones Lang LaSalle, but more and more we're doing a lot of portfolio evaluations for larger organisations such as local authorities and again, as I mentioned, university campuses. Now, in order to get your CPD certificate at the end, I need to tell you a little bit of science. The chap you see on the left is William Herschel. Herschel was accredited with the discovery of infrared back in the 1800s, and his son actually took the very first thermogram. The right hand side is John Logie Baird, a tremendous Scotsman whom you've no doubt heard of, who basically invented the Noctovisor, which was the first infrared camera. Now, the experiment you can see on the left hand side in the movie is Herschel discovering infrared, and basically what Herschel did was repeat Isaac Newton's experiments, splitting white light into the visible spectrum. Herschel then moved a thermometer beyond what he could see, and he actually recorded a higher room temperature, higher than ambient room temperature on his thermometer, and that's how he discovered infrared. He realised there was an energy source there that he couldn't physically see with the naked eye. Very sharp guy, and proof that men can multitask. Herschel was a musician, astronomer, chemist, advisor to King George, very, very sharp man indeed, and as you can see, part-time actor. Now, what happened since John Logie Baird? The cameras first became commercial, and you looked like this sort of Ghostbuster chap here on the left. You had 2 bottles of liquid nitrogen to keep the camera cold. You had what in effect is like a car battery to power the thing. You had a VHS tape recorder to actually physically see the images, a nice periscope to look down, and a sensor head in your hand. Now, these cameras were very expensive, very cumbersome, not the best ergonomics as you could imagine. In the 1990s, the cameras went digital, and they came down drastically in price, down to about £40,000. So much like the old mobile phones of yesteryear that some of you will remember. Not everyone who was brought up on iPhone 4s, but everyone else. Cameras later on came down to about £15,000, then down to about £8,000, and today you can get these beautifully ergonomic, nice, simple handheld cameras for around £8,000. And they're very, very nice to use. Now, normally when we do these presentations face to face, we get you involved, but as this is a webinar, we shall just have to tell you the defects. This image that you can see in front of you, it's a 3-storey house. It's had its attic converted, and you can see very clearly this blue triangle at the top here is very well insulated. It's cooler on the spectrum here. So what the camera does when you first switch it on is it says the coldest thing I can see is minus 15.8 degrees. I'll make that black, that's the night sky. The warmest thing I can see is 1 degree. And in this image it happens to be the lintels above the windows. So there's a few things you learn from this image straight away. First of all, you can see that the lintels are causing a thermal bridge. So you can physically see the energy leaving the structure. Around everywhere that's white, you can see it at the window sills down here as well. You see this well-insulated attic. You see a well-insulated roof here. No insulation in the side of the dormer construction here. You see a blocked-in window here. You see a nice crack in the building over here. And those things, they tell you an awful lot about the structure. As any building surveyor listening will know, you can't find those things out unless you start drilling holes physically in the fabric. And if you do a destructive test in that building, you would have to drill hundreds of holes to find out where the insulation started and stopped. So from this thermal image, which takes seconds on site to physically acquire, you found out a quality assurance issue in that the contractor didn't insulate the side of the dormer. You found an opportunity to fill that house with insulation because it's got no insulation. The cold bridging would tell you that it's a cavity construction. And most people in the audience, you may well be asking, why is this window blue and this one blue-green? That can be lots of things. That can be low emissivity glass in one and not the other. It could be the curtains are closed in one, not the other. It could be that this one is reflecting the night sky and this one's reflecting a cloud. Glass is particularly difficult for infrared to analyse. Now this next slide, this is basically all we're doing here is changing the level and span that we're actually trying to analyse. So anyone with a thermal camera can do this very, very quickly as you see on the screen. We can basically take a thermal image and tell you any story you like. We can make it bright red and say, hey, you should buy our insulation. We can make it blue and say, I've just built it, it looks absolutely fantastic. And what you're actually looking at there on the left hand side of this structure, it's a 9-inch brick construction. You can see it's the header and stretchers going across the span there. Everything that's blue is actually porous brickwork. So it's one of the importances, if you are considering an infrared survey, that you do make sure whoever's doing it is completely 100% impartial, because it is very simple to tell you a false story. Now also, integral to infrared is actually understanding what you're looking at. This is a little experiment. It's a highly reflective stainless steel kettle on to boil. The cursor temperature, you can see a crosshair in the middle of the kettle. Its temperature has been recorded in the top right of the screen there, and it says it's about 23.5.6 degrees. If you look closely, you'll see steam starting to come out of the spout of that kettle. And basically you know that should be saying, well, if not 100 degrees, very, very close to it. So the exact same experiment, if you actually set the camera up properly, i.e. you can cut out the reflections and you set what's called emissivity correctly, you will get very, very accurate results. And this little movie goes on to show you that. All we've done here is stick PVC insulating tape to that kettle and repeat exactly the same experiment. We sped it up a little bit so you don't fall asleep. Hopefully you're still awake at this point. But you'll see the temperature. Up she goes, it's up to 40 degrees, 50 degrees, and so on. And it actually peaks out at about 98 degrees. And that is the true external temperature of that kettle. It's glowing white hot, it's off the scale, and you can see the steam coming out of the kettle. Now the importance for the building market itself, if you can imagine taking a photograph of a building, you might have an exposed brick substructure, you might have a rendered superstructure, you might have a bit of timber cladding, a bit of stainless steel cladding, some glazing. Each one of those materials will look completely different unless you set the emissivity correctly for all of them. And it's something that's very often overlooked by thermographers who aren't specialists in buildings. Thermography is very, very specific. You cannot survey if it's 21 degrees in the building and 21 degrees outside the building. Energy physically has no incentive to move, and it doesn't move. So you will take a picture and every building you photograph will look fantastic. Same if it's wet. If you imagine rain, a sudden cloud burst, and you take a thermal image of a building straight after it, the building will look fantastic. It's nice and cold, and it will look well insulated. You won't see any defects. So rain is an absolute necessity. We need dry conditions to do these surveys. Same with wind speed. If you get high winds, you can imagine as soon as that energy leaves the building, it physically blows away. So the best advice is make sure there's a good temperature differential. Around 10 degrees is ideal, either by forcibly having the heating on, that's okay, or by ensuring that you do the surveys in winter time. Evening time is always recommended. You really want to be there 2 hours after sundown. That's mainly to allow what's called thermal inversion. The building absorbs energy from the sunlight all day long and from the building itself, with the heating being on and occupants running around inside. We really need those factors out of the equation. If you survey a flat roof, that's okay. You can actually survey, if you get a beautiful summer's day, all the wet insulation in the roof will be heated up by the sunshine itself, and then at night time that energy will start to radiate. So you still will see big differences, even though the internal structure of the building might actually be air conditioned. That doesn't make a huge difference. It's the physics behind it that's important. Now with building defects, which is our biggest market, you all know the problems. If you strip off a roof to replace it, for instance, you've got the disruption to the tenants. The actual occupants may have to move out. They will most certainly complain if they have to do either of those things. The sheer disruption of scaffolding a building, ripping off a roof, skips on site, shoots down the side of buildings, is very disruptive, and it's very, very unnecessary in a lot of cases. Beyond that, you've got the actual exposure to the building. The second that roof is off, if it rains, you're sitting there with a massive liability. You also have reports from various people selling various products. If you commission someone to come out who happens to sell cladding systems, for instance, or roofs or air conditioning units, can you truly rely on that advice? Ultimately, are they making money from selling you products? So our solution to that conundrum is to say to you, look, let us go and photograph them. What you're looking at there is a photograph of a flat roof. The white thing in the middle of the image is an air conditioning unit on a flat roof. And what you can see in red and yellow, this nice big blob, is saturated insulation. Very, very easy to see. We didn't have to cut any holes in it. We didn't validate any guarantees. Very simple, very graphic, and very easy to go back to your client and say, here is the problem, and it came from this aircon unit. So you actually know who to blame as well. Compared to scaffolding the building, it's incredibly inexpensive. It's very graphic, it's nice and visual, and it saves you a whole heap of time. It's also accurate. There's no ambiguity. It's a picture. You can literally go on that roof and cut a core sample in the red area. It will be wet, and cut a core sample 6 inches away in the blue area. And the beauty of our company is we physically don't sell any products, so it is 100% impartial advice, just like yourselves. This is a case study of a project we did in Edinburgh. It's 90 schools, some primary, some high schools. We did every roof, we did every elevation, and ranked and rated their entire stock. And what we delivered at the end of that project was a spreadsheet that ranked and rated each building against each other, but also against themselves. So the client was able to put together a refurbishment program that was very, very specific with a known return on investment from day one. It was a lengthy project for us. It was 8 weeks, but because the way our company is structured, we were actually taking photographs in the evening, but simultaneously during the daytime, when our surveyors were asleep, we were physically writing the reports. So it wasn't as long as some of our competitors, which would have been, I guess, 15, 16 weeks. We managed that in 8 weeks. Here's a lovely little horror story for you. This is a before and after case study of a flat roof in England. The clients shall remain nameless. What you can see in front of you is a nice flat roof, which has got red and yellow and green moisture trapped within it, which you can see pretty much everywhere on that surface. Now the alarming thing, we did a before survey, showed the client the images, and he went away and spent £250,000 replacing that roof. At the end of it, the building still leaked, and we were called in again to find out what had gone wrong with the refurbished roof. And what you can very, very clearly see in the screen here is a purple area. Apologies if you're colourblind, but I'll just circle this area here. This area is perfect. That is a brand new roof. It's excellent insulation and it's in fantastic condition. Everywhere else is just overlaid. So all the old problems are still just trapped underneath the system. As you can imagine, that one went to court, but not before we had the pleasure of cutting a hole here and a hole here with the contractor in attendance. To prove the point, and there were two completely different specifications under there. It was a very enlightening survey. This is a good news story. This is a supermarket in Thornaby-on-Tees in England, and it's perfect. The roof ends here, and everything in the foreground here is a beautifully insulated uniform roof. This red area here is actually an air conditioning unit sitting in the foreground. These green areas are the headlaps and the felt, and the side laps. As part of a QA process, just on handover, the roofing contractor instructed us to say, I'm handing over this job, I'd like you to say it's perfect, so that in the future, if anything goes wrong, I've got a visual, accurate, independent record that I handed this roof over and the insulation was continuous and there were no penetrations through the waterproofing. Now, over the years, we've done a fair few roof surveys and invested in a vehicle with a 21 metre pneumatic mast on the back. So you can see our thermal camera at the top here, which is quite precarious, as you would imagine. It makes a Scotsman very nervous to see his £25,000 camera swinging around in the wind that high up. It does have two-stage guy ropes to stabilise it. You can just faintly see them in the photographs. You can see ropes at the top here going out that way, and about halfway up there's another stage of guy ropes to secure it. But it's fantastic when you get a roof such as this one where there's no edge protection, there's no man-safe system, access might be limited, you might have a fragile roof deck. The thermal camera and the mast van together allow you to take a nice clear shot and say all that yellow, all the red, all the green, that's your problem area, strip it out. Now, all of that was caused by someone stealing the lead from this junction here. So it's a nice clear indication of where the problem is and how it arrived. Now you could core sample this at high points, you could core sample at low points, you could core sample at mid points, and you wouldn't find that defect. So I hope you like that image, it's quite a powerful one. Electronic leak detection I mentioned earlier. This in essence is an electrically charged brush. Here these bristles are phosphor bronze. The system's charged to about 40,000 volts depending on how thick the insulation material is. You have an earth wire here that you earth yourself to the parapet, or in this case the window cleaning cradle system along here, and effectively you sweep the roof. This is on a single ply system, and essentially any penetrations in it, the system can make a bridge, so you get a nice beep and an audible spark and beep, so you can physically spray paint on the roof there and then. The reason we mention this service is it beautifully complements infrared. You can get right into the details, do the parapets with these smaller heads on the brush. and actually say we found 52 holes and here's the thermal image which proves where all the resultant damage has come from. Probably one of the largest projects we've done with that was the new Terminal 5 at Heathrow. Having started in the roofing industry in 2002, it very quickly spawned into cladding systems. We've got numerous projects where the roof was actually okay, like this image here. The roof was okay. This is 24,000 metres of roofing surveys. But the cladding system, you can see here in light blue, in green, yellow, that's all water getting into the cladding system. Now that, again, that was a 5-year argument between landlord, tenant and 2 sets of building surveyors. And they'd basically been looking in the wrong place for the whole 5 years. We solved that in one evening for them for £3,500. And everyone was very, very happy, very delighted with that service. When it comes to houses, this is an image we did for the BBC Watchdog programme. You can very clearly see purple and black areas in this house. This is literally cold air ingress within the structure. Very simple, very easy solution. Now this one is in South Wales. This is a part of a BREEAM assessment. We did air leakage testing on it. Building passed with flying colours, no problem there. But when we switched on the infrared cameras, you could see all this energy escaping along the eaves junction up around here. Now this was actually caused by a 75mm gap above this I-beam you can see running around the perimeter here. The insulation was actually quite tight, you know, it did butt against it quite nicely, but the fact the U value was different above it caused this gap here. Very, very easy to remedy. They simply jammed that 75mm gap with polystyrene, so it was a nice, simple, cheap, economic fix. More alarmingly, the area you can see in the thermal image at the bottom, which has got a nice little white square around it called AR1, this area here, that's around there in the visual image. That we had to open up. We had to get the contractor back to physically open that for us, and in that cavity he found pallets. He found fleece jackets, bottles of Coke, bags of rubble. Basically the cavity was completely blocked. So a very nice non-destructive way of saying there's a problem there, but it led to a destructive test to finally prove what it was. Moving on, render surveys. Because the cameras are fully digital, we can actually take a photograph of a building and say, please apply a nice green colour to everything that looks like it's delaminating. It's very, very simple to do. That we can do in a matter of minutes before you've even ordered scaffolding, never mind it arriving on site and erecting it and trusting Bob and Jeff, the render specialist, to physically hammer test it, which I'm not sure if you've ever seen it, but it's quite a laborious test. The client gets annoyed because you're banging on his house. And bizarrely enough, if you hit render, it falls off quite regularly, particularly if it's delaminating. So there's no risk. From infrared, there's no risk on that side. It's very, very fast. It's very inexpensive. And your tenants will thank you for it. Now moving on to the energy aspect. The ethos here for us is that if you see more about that structure, you will learn more about it, and that will lead you to save more money. The problem we find most people have, despite there is legislation out there, but it's a quagmire. It's very, very confusing and complex to get your head around where to start. Everyone knows the energy prices are going up. They are not coming down anytime soon. The low-hanging fruit, the easy stuff, most clients have done. The light bulbs are done. They might not be able to afford a brand new roof, but where do you go next? What is the problem? And what's the solution? So our solution's a little bit unique in that we physically take infrared images that allow you to rank and rate those properties very, very quickly on a spreadsheet, which then enables a nice fast decision-making process from your board of directors or your client themselves. It makes auditing at large portfolios very, very fast, and it is quite engaging. You will get homeowners and commercial managers engaged in that process. But what's unique about the software here, what you're looking at in the image in the bottom is a well-insulated home on the left and a poorly insulated home on the right. Side by side, semi-detached homes, and all ranked and rated again. At the bottom here you'll see a green stripe that we've added to the image. This is all patented by IRT, And what we've done is written software that can put a value against those pixels. We work out how much energy it represents. We then cross-reference that back to how much CO2 it represents, and we factor in the actual energy cost itself. So we can literally knock on that person's door and say, you are wasting £347 per annum. The images are also stamped with a nice big traffic light system. The more red in the foot, the worse the image. This one's bang in the middle because you've got a perfect house and an awful house. These images were done with British Gas up in Manchester. Now, it's one thing to point out a client's problems. It's another thing to give them clear recommendations. Infrared thermography is a little bit of a mouthful, so we changed the name to It's a Carbon Diet Plan. Most people know what a diet plan is. Carbon is, inverted commas, weighed in tons like this, so we thought scales was a good thing to represent the process. So we weigh the house with infrared at the start and say, here is your problems. We then produce a diet plan that says, look, if you either turn the heating down, you insulate the walls, you replace the glazing, you change your boiler, you do draft proofing, here's all the recommendations. And then we come back at the end and we take another thermal image to make sure it's been done correctly. So it's very, very simple, it's very low cost, and it does engage the tenant themselves. When we're talking about commercial buildings, it's a little bit more complex, but the theory and the principles are exactly the same. Large-scale buildings, we provide plans for the building showing you exactly where we were standing when we took each image. These plans can be 2D or 3-dimensional if you prefer. We then match up visual images with thermal images all the way around that structure. We have cumulative losses in the right-hand side here. We give you a notional EPC certificate, and we give you energy consumption throughout 12 months of the year. Then again, we go around the entire fabric and match up every thermal with every visual, and then we give you recommendations. Now this can be 50 pages, 500 pages, or in this case 2 pages, so you don't, again, fall asleep during the presentation. We can then give you options. If your client says, hey, I'm thinking of double glazing or triple glazing, we can simulate them and we can show you the likely savings from both of those options. Here on the wall options, we can give you what if I just correct anomalies because I have no budget. There's the year 1, 3, 5, 10 year savings. What if I externally clad, or what if I internally insulate? Or you can do it by U-value. It's very fast, again, it's very cost effective to do this, and it uses the exact same criteria as a full SBEM, the Simplified Building Energy Model, to create it. And if it's a domestic house, we're actually taking on board the SAP data, the Standard Assessment Procedure, to create that. So it's not just the thermal image where this data set's coming from. We actually need to know the building size, the orientation, what it's made of, what the heating type is, how efficient it is, how much do you pay per kilowatt, where about in the country is it, etc, etc. Now then, to complete that journey, what we've created is a carbon dashboard where the client themselves, or you as a consultant, or whomever you happen to be, you can very, very easily interact with it. This is created, you log in, you type in a password, and the dashboard website picks up that SBEM data, and then you can do free SBEMs. You can do them as often, as many as you like, completely free of charge. Now if you prefer, you can switch the diet plan on, and then you've got 4 choices. You've got building regs, you've got energy saving, energy rating, or CO2 savings. So here we're demonstrating, look, what if we take it up to a D from an EPCG? Or we can say, look, what if I want to make 10% energy savings or 5% CO2 savings? On this instance, simply take it to building regulations. So you click calculate, and what's happening in the background is that the software is doing every single permutation or iteration of SBEM conceivable. Tens of thousands of them are done back to back, and it then gives you recommendations based on that. And this is physically how long it takes to download. Sped up a little bit again because it's the nature of the presentation. But this building is basically saying, look, it's an F today, you could get to a D, and here's the things you can do to achieve that. And it comes out in a step-by-step guide. Improve your walls, improve your boiler, your roof, windows, draft proofing, lights. That's how much you should save in money, CO2, kilowatts, and the likely return on your investment. and again it's all done step by step. This report also, it does say infrared surveys, IRT surveys all over it, but it can quite so easily be your own logo that's on there. We're quite comfortable dual branding these things. Now again, when it comes to portfolio evaluations and large scale stock surveys, most of our clients prefer this as an output. Nice easy spreadsheet, images embedded. We've got energy loss, CO2 and cost at the top, and the full address of the house itself, and a little thumbnail on the left hand side which you can easily enlarge. Now the beauty of it integrating with Excel this way means you can play with it properly. You can create pie charts, bar graphs, you can section it any way you like. For instance, if you're doing a eco or a green deal assessment, you can simply click where's the most carbon and it will prioritize it in that order. In this example here, this was 10,000 houses we did in Scotland, and you can drill into it and you can compare town by town. This is comparing Belsill to Blantyre, which are two small towns just outside Glasgow on the west coast. Or you can go further. You can say, look, compare 3 cities, or just show me one particular street. So the whole point of this system is that it's enabling you very, very clear insight as to where to start. How do you save carbon? Where's your biggest return on investment? What's your best bang for buck, as our American cousins would say? And that's all there. It's all readily at hand for you. So I'll just move on from this slide because you can play with this to your heart's content. The key benefits of this sort of survey is, well, it's all listed on the left. The speed that we do a survey. We can literally do a survey on site in 1 day compared to an engineer going in for 2 or 3 months. Every competitive product on the market is theoretical. If you look at SBEM, for instance, what our software is based upon, it is all theoretical. If you say, I've got a cavity-filled construction, SBEM assumes that that cavity is full, that it's never degraded, it's never slumped, and it's been built perfectly. Whereas IRT actually takes on board that, perhaps it might have slumped. Maybe the building's 20 years old. Maybe it's not there. Maybe it was not done correctly in the first place. And that speed and that accuracy, saves our clients a huge amount of money, but actually saves them right from day one, because we don't need 3 months and 50 or 80,000 pounds to do a survey. We need about 5,000 pounds to do a dashboard, a diet plan, and an infrared survey. You also, as from a client's perspective, you don't need to be an expert to understand our reports. They are very, very simple. Your clients will understand them. And again, if you want to access it via your mobile, via your iPad, your iPod, whatever else, it's very, very simple. So at the moment on the market, as of November 2012, it's the only visual energy auditing tool set on the market. And we hope that you love it and embrace it. Where does it fit with you? Big market for leak detection. Obviously on flat roofs, we've been doing them for 11 years. Stock evaluation, we're doing more and more housing stock. To date, we have done about 200,000. It's a very fast, easy, simple conflict resolution tool. Never had any surveys go to court in our history. It's a fantastic tool for QA. Any quality assurance projects, it's absolutely fantastic. We get lots of refurb projects when people are trying to make that decision between, do I need to strip a roof or can I just overlay it? It's a fantastic tool for that. BREEAM assessments we're getting more and more of. You do get credits for doing an infrared survey. Portfolio evaluation, again, we're doing more and more of them, where clients are saying things like the upcoming legislation in 2018 says you can't rent a building if it's not got an EPC that's at least an E. Now that's very confusing. If you've got a large portfolio, where do you start? Which half of your portfolio is good? Which half is bad? EPCs are wildly inaccurate. There's something like 85% non-compliance in the EPCs that have been done. So again, our tools can go in and give you a real benchmark. Where do you stand today? What's the roadmap for the future, and how on earth are you going to get there? Historic buildings, not a massive market for us, but it is a nice tool if you're trying to analyse a pesky defect that's been ongoing for years and years. Things like the carbon reduction commitment, Again, it's quite a big driver in the market. You get taxed on carbon emissions. You've got to find out where they are. You have to make year-on-year savings, and infrared enables that very, very simply. We are very keen that clients embrace a sort of building MOT so that we find defects when they're small before they become big and expensive. And also, again, we're just beginning to see people actually use infrared to ascertain the value of a building before acquiring or disposing of it. Things like dilapidations, again, we can go around a building very easily and spot defects to get them put right before a tenant moves out and hands things back and money is settled. But if you're buying a portfolio of buildings, what a fantastic tool to go around and actually help drive the price down by spotting lots of defects that the naked eye would simply miss. So that is our very last slide, folks. I hope you've enjoyed the presentation. I hope you dialed in and made it all the way to the end. It is unique. It's patented. We are the only people in the world doing this as a end-to-end service like this. You will benefit from nice clear photographs, and the accountants amongst you will love the numerical results where you can actually see the bang for buck nice and clearly. Moreover, your clients themselves will like the interactivity and the fact it's online and free. As I said right at the beginning, we have local branches everywhere, which makes us the lowest carbon footprint infrared building surveyors in the country. So whether that's high on your agenda or not, it's a fact. We don't travel the length and breadth of the country to come and tell you you can save 1 tonne of carbon and having burnt 10 ourselves getting there. The way our business is structured, you will get uniform service, uniform pricing, no matter where you are. You can be in Outer Hebrides, Orkney, Shetland or Land's End. It doesn't make any difference. It's very, very fast, it's non-destructive, and I hope you find it compelling, and I hope you find your clients find it engaging. And as I said, it is supposed to be nice and simple. And with that, I will sign off and thank you very much for your attention. Hope to hear from you soon. Thank you.